Uh, Let me share the screen and start the session. Okay, starting. Artificial intelligence in electrical engineering. Okay, that's the topic we are going to speak on today. Before starting, let's first understand what is AI and a few introduction about artificial intelligence and recent advancements in artificial intelligence. And let's speak about how AI works, the architecture, and let's demystify AI. And then let's go in deep with how AI can be implemented in electrical engineering. So this is the agenda for today. And so, what's AI? Actually, when we think of AI, we think of robots and autonomous cars, self-driving cars. But nowadays, AI is a lot more than that. It's in our everyday life, and we see it in almost everything we do, and what all the technologies we use. Everything there is AI implemented already. So if you see Siri, Google Assistant, even Google Search, under the hood they are using machine learning and AI actually. So also if you see the Amazon recommendation system, Netflix recommendation system, so these are all machine learning algorithms that are analyzing your past data and then your giving recommendation based on your interest. So also image recognition software, even TikTok, Instagram. So they do face manipulation by using computer vision. So we see AI in almost all fields, and it's good for us to adapt to the new situation. And almost electrical engineering and power generation, power consumption, everywhere they are using AI nowadays. So it's for us to grab up the opportunity and learn AI now. So before going in depth about AI, let me share a few recent advancements in AI. So there are two main branches in artificial intelligence, that is natural language processing and computer vision. So what is natural language processing? So actually when we think of AI, the main objective of AI is to mimic human intelligence. Humans can speak, understand and communicate with each other. So hello, okay. So NLP helps computers understand, interpret, and manipulate human language, like in the case of Siri, Alexa, or Google Assistants. So those are all actually NLP models. And also humans can see, recognize objects. So in the same way, computer vision enables machine to see and interpret the content of digital images such as photographs and videos and understand the visual world. So let us see few latest advancement in these two major fields of AI. First, NLP. So if you see here a small clip, here a person is giving a description about what he wants as a layout for a HTML page. So when he just types the description, the NLP model was able to design the actual web page and give the HTML code. So think it think of this now, like there is no need for us to code or learn the code in the upcoming years. Just the description, we will get the code and let's get going. So AI is made available for everyone, even who doesn't know programming languages. So we see the same thing here. A person is just typing what he needs for a web page. So just he wants to say Google page. So just with the description, it's able to create the actual Google web page. So that's the power of this recently developed generative pre-trained model, that is GPT-3, GPT-2.3. Actually, there were a lot of models have been trained beforehand, but this is the recent advancement, that is GPT-3. So let me just say how it's able to do this fluently. Right. Mm, I missed a slide. Okay, so What is GPT-3? So what is actually NLP? So NLP is actually the natural language processing. So they have designed language models that uses deep learning to produce human-like text. So if you think of this language model, it's nothing but predicting a new word. When given a sentence, I study in volume engineering, dash, it's able to predict what is the next coming word, that is college. So that's how the model has been trained. But the thing is, this AI model has been trained on humongous amount of data. That is 4 years of internet data. That is all web scraped and then put it into the model to train with this data. So if you give all the Python code for it to train, if you give a description as an output label, it is able to code the Python, give the Python code with just the description. That's how it has done the previous thing of HTML. So this is how we can do with the NLP model and language models. So if you think of this GPT-3, which has been trained on 173 billion parameters, there is another one recent advancement that is released last month from Google, G-Shot. The model name is G-Shot and it is having 600 billion parameters. So the actual model is not yet released. It is not yet made open source. But if it has been released, it would have been a major advancement in the upcoming years. So like this, there is a lot of language models that have been coming up. So it is good for us to keep up to date on this NLP thing as well. So let me go to the other part, that is computer vision. So we see a video here. This is actually I coded it, and see here it's able to predict all the cause and persons by just going through the video. So if you see here, the actual model is here, object detection model. So just by putting into the video, it's able to take each frames and predict what are all the objects in that video, like 1%, 2%. Here it's able to predict birds, airplane, like that. So just that by giving a video into a pre-trained model, it's able to detect objects efficiently. So we can put any video or any images or anything after to the pre-trained model. It's able to predict the objects in the video. So this is the basis of uh, autonomous car vehicles that are running in Tesla or Google cars as well. So this is one of the tools that is needed for autonomous cars. So it's actually very easy to do. So let me explain how it's actually functioning. So first, to train a model like this, we must have a lot of humongous amount of data that has images or videos that are labeled like this. So the manual person, the actual person, has to label it like this is the car, this is the person, by drawing a bounding box of the object and give the data to the model to train. So once the model is trained, it's able to divide each image. So after giving all these images, the model will, when given a new input data like a dog here and cycle here, the model will draw numerous amount of bounding boxes like this. If you see in the bounding box plus confidence image, it's able to draw a lot of bounding boxes, and which bounding box is more thicker and more confident, it will make that as our output, like this final detection. It will detect the dog, cycle, and a car like this. So it's as simple as this, like just we have to give the input data and make the model predict, and this model can be generalized and used for any kind of video or any input we give. That's how I have done here. Like even you can give any video here and then just make the model predict. So that's a few advancement in NLP and computer vision. And this is another one. Just we can try it in online. It's a website called Sketch to Code. When given a hand-drawn uh, tabs or like this, it will just predict what all the things that are there in these drawn images and give the HTML code of this. So just by giving the drawn images, it's able to give code. So that's one of the cool things that I found. Okay, then so enough of the advancement in NLP and computer vision and AI. Let us go into the basics of artificial intelligence and learn what all the branches that are there in artificial intelligence. So if you think of artificial intelligence, it's nothing but science or like mathematics or biology that studies the ways to build intelligent programs and machines that can creatively solve problems. In simple words, machines doing stuff autonomously. So in in this, there are a lot of branches in artificial intelligence. One such branch is machine learning and deep learning. So machine learning is nothing but a subset of AI that provides systems the ability to automatically learn and improve from experience without being explicitly programmed. So it's just a set of algorithms that when fed data learns the pattern in the data and tries to get meaningful insights from that data. So everything that we are doing with the AI and machine learning that needs labeled data or humongous amount of input data for it to train and then learn and then give a predictable output. So one more major thing in deep learning, one more thing major thing in AI is deep learning. So deep learning is again a subset of machine learning, which uses the neural networks to analyze different factors with a structure that is similar to human neural system. So if you think it's just like neurons in the human brain. So how the human brain functions that has been mimicked as deep learning. So we will get into deeper into each of these branches. So first, let me go through some of the basics of AI. So first, the AI has been in prevalence before some 70 years, like in 1950. The AI has been there, but the thing is, at those days, there was not enough computation power and data to for AI to evolve in this field. So after a few years, like recently, we have a humongous amount of data, that is big data. Like we see this side, for every minute of the day we are generating like trillions and trillions amount of data, like from Facebook and YouTube, and there are a lot of things that we are doing. Each thing we do in our mobile is generating a data. So with this humongous amount of data, every company wants it to analyze the data and make it useful for their business or for their customers. So that's how AI comes into play. Like it's a very important field right now, like for the people to analyze the data and make it useful for everyone and for their customers and for every field in the industry. So how neural network like artificial intelligence is being used nowadays. So first, we need a humongous amount of data to train the model, and to train the model, we have GPUs and high processing units like TPUs, which have been used to parallel processing and effectively train the model and use it for predictions. So we have also come up with a lot of softwares like TensorFlow and PyTorch, which have been made easy for the people, even with non-computer science background, to easily learn AI and use it in their fields of interest. So let's first see what is machine learning. So as I have said already, machine learning is just a set of algorithms that when given a data, it will learn the algorithm and then predict the output of itself. Like if you see most of the people who have been come from computer science background in 11th would have seen the code for the Fibonacci series. So if you see here, this is the old way of doing Fibonacci series code, that like we have to define the algorithm each by steps, and This is how we usually do the programming. But with the machine learning, we no need to do the steps of algorithms that the machine has to follow to get the output. We just need to give the input. That is, for first number it's 1, second number is 1, and third number is 2, and fourth input is 3. So Fibonacci series, just we have to add the last two digits and to get to the actual output. So when given just the input and the labeled output, the machine will understand what's happening, what is the relation between this given input and given output, and try to design the set of rules algorithms by itself. That's the beauty of machine learning. It's just by giving any input and the output, the machine will draw a comparison between this input and map it to the output, and design a algorithm by itself. That's the machine learning in a nutshell. Um, if you see here the simple diagram here, just by giving the data, the machine is loading the algorithm and then predicting whether the given data is apple, orange, or cherry. So to just give you a little bit intuition of what machine learning is, let's take a simple example here. So we see here, if you have a data set that has weights and height, if you want to predict the height of a person by giving a weight, then a simple model like linear regression has can be used. So given the input data of weights, the machine learning model will plot the graph like this. Like think it as a two-dimensional graph, which has weight as in the x-axis and height in the y-axis. And for the corresponding weight, what is the height? It will just plot all the points here, and then what the model will do is it will try to predict the best fit line that can be generalized for this input and output data. So if you see here, for what the machine learning will do is it will just randomly draw a line that fits this all these points. Once the line is drawn, what it will do is it will calculate the difference between the drawn line and the actual point in the plot. It will then find the difference of the loss, like what is the difference between the actual point and the predicted point. So once the difference is found, that's considered a loss in terms of machine learning. So this loss it will try to reduce in the next iteration. So with the consecutive iteration, it will just draw a perfect line between after doing 50 to 100 iteration, whichever is based on the data. So it's just drawing a simple line by reducing the loss function. So that's the simple introduction of linear regression. So when we come to the next simple algorithm like decision tree, if you see we want to classify uh, an animals based on a set of animals, what the machine learning model will do is it will just first see whether based on the data, if you have the features like color, height, and weight of the animal. So what the machine learning model will do is it will just classify the animals based on the color, and then classify the animals based on the height, and at last it's able to classify each animal and put it into the separate leaves in the decision tree. So by just giving input data of color, size, and weight of an animals, it's able to distinguish each animals in a simple way. So this is just a quick overview of a few models in machine learning. So next, let's get to what are the types of machine learning that are there right now. Like for there are overview of three simple machine learning types, that is supervised learning, unsupervised learning, and reinforcement learning. So what is supervised learning first? Supervised learning is where you have input variables and an output variable, and you use an algorithm to learn the mapping function from the input to the output. The goal is to approximate the mapping function so well that when you have a new input data, that you can predict the output variables y from the data. So if you see here, the data has consider the data as cat and dogs, and we have labeled the data by giving the picture this is a cat, and giving another picture this is a dog. And when the label data is given, the model will train and create its own algorithm, and then predict when a new image comes, it will predict whether it's a dog or cat. So that's a simple way of saying supervised learning. It is called supervised learning because the process of an algorithm learning from a training dataset can be thought of as a teacher supervising the learning process, because we are giving the input data along with the labeled data. So that's the way of teaching the model. So this is the output for the concerned input. So in supervised learning, we have two major things, that is classification and regression. A classification problem is, as we have seen, the distinguishing between a cat and a dog. So when the input variable is a category, so it will separate the particular category in the particular box. So if you see the diagram here, when given the input data of tomatoes, the model is able to dis- create an algorithm for it, and then train based on that given input and the labeled output. And when a new input of similar images of tomato is coming, the model is able to predict that. So there is another one distinction in supervised learning, that is regression. A regression problem is when the output variable is a real value like a numbers and a weight or height, like we have seen here in this example, like the values are a continuous range. Like when you wanted to draw a best fit line, those kind of things are called regression. So this is the overview of supervised learning. And what is then unsupervised learning? Unsupervised learning is where you only have input data and no corresponding output data. Like we don't give a output label. Like when you give an image, we say it's a cat or dog in supervised learning. But in unsupervised learning, we just put in all the data and without labels. We don't say it's a cat or dog. We just put the mixture of all the images into the model, and the model will distinguish based on the features it's finding in the images, and then classify or cluster the images, and then give the separation of both the images. Like it won't say it's a cat or dog, but it will classify, separate, this is another group, this is another group. So it will just separate those things. So the goal of unsupervised learning is to model the underlying structure or distribution in the data in order to learn more about the data. So it will just try to learn the features and try to understand the underlying pattern in the data, and then just classify or cluster it based on whatever input you are giving. So these are called unsupervised learning because unlike supervised learning, above there is no correct answers, and there is no like kind of teacher or output label that supervises this is the output label, like that. So algorithms are left to their own decisions to discover and present the interesting structure in the data. So this can be very much useful when we want to group the uh, group things or cluster things. Like in case of we think of Amazon, we have a categories of various products. So instead of classifying manually the products in the Amazon, they are using just this clustering algorithm, and it will just cluster based on the images that have been put into as a product in the web page. So if you see, there are two main use cases of unsupervised learning, that is clustering and association. So here in clustering, when given an group of lot of input data of apple, banana, or other foods, the model will try to cluster or group the images that are relatively look alike or relatively close to each other, like all the apples together, all the beach together, all the bananas together. So that's the simple overview of unsupervised learning. So There is one more interesting type of machine learning that is called reinforcement learning. Uh, in spite of us giving an input and uh, output in case of supervised learning and no output in case of unsupervised learning, what reinforcement learning does is it creates its own algorithm based on the environment it is there. Like it try to learn to react to an environment on their own. To be little more specific, reinforcement learning is a type of learning that is based on interaction with the environment. Like in case of if you have seen OpenAI that they have designed a game like this. So what it does is, so if you see here, the so these are like agents that have been designed by the OpenAI team. What it does is the model tries to analyze the environment and try to escape from this good guy. So what it does is first the model was unable to adapt to the situation, but after a few consecutive iteration, few consecutive tries, what the model tries is it learns the environment and understands the situation and then finds this box and blocks the person from entering. So this is the just an example of reinforcement learning. So most of the video games that are coming up now are going to use reinforcement learning, and it's like how to say the to explain the process of how it does is if if an agent completes a level, it earns a badge. So if the agent defeats a bad guy in a certain number of moves, and it will be given a bonus. If it doesn't do that in the right way, it will be given like a kind of punishment, or in terms of machine, what is bonus is if you give more weights, like if you give +5 to the model, it weight will increase. If you give -5, it will take it as a punishment. So the model will try to understand the environment around it and try maximum to get the maximum bonus of +5. So that's how the model will be trying to achieve its success. So reinforcement learning operates on like same principle. Actually, like in games of video games, as you see, so the common test environment are given for research, and then the model, the agent tries to adapt to the situation around it, and then um, get the best success of the learning. Okay, so this is the just a overview of the types of machine learning. There are other types as well, like self-supervised, semi-supervised. So those are just the subsets of supervised and unsupervised learning. So if you see in case of GPT-3, which I have shown already, right here. So if you see here, it has been trained on 4 years of internet data. We cannot manually go and give the output of a label or make it as a supervised learning. In case of humongous amount of data, what we does is we do it is in a self-supervised way. Self-supervised way means, as I said, you will be having a sentence and mask a particular word in that sentence and make the model predict the particular word, masked word. Like in case of I said, um, I studied in engineering dash, and the model will try to predict that particular word. So the model will be given the sentence and with the masked word of college, and when the model trains and predict it as university, the output will be shown as college, and so the model will understand so it's wrong and get back to the again the iteration will start, and then the model will try to make it as prediction as college. So that's how the model learns in case of self-supervised. So this is just the overview of machine learning. So when we go deeper into things, there is something called as deep learning, as we have discussed already. The deep learning uses what is called as neural networks. Actually, it's called as artificial neural networks, which has three layers: an input layer, a hidden layer, and an output layer. So first, what is a neural network? A neural network is just a computer program that operates similarly to the human brain. Think it as neurons in the brain. The objective of neural network is to perform those cognitive functions that our brain can perform, like problem solving and being teachable. So this is how our brain, when a neuron is activated, that's how we collect the cognitive information in our body and then process it. So the similar way, what we do in neural network is, it's, to put it in simple terms, it's just a mathematical function. What the mathematical function is, let me show here. So everyone would have learned the matrix and like matrix multiplication. So all the neural networks that we see today are just doing this matrix multiplication, but in a bit more complex way, like in a more dimension, it will have a more dimension like that. So see, if you see here, when we give an input, the model will try to randomize the weights, some random weights, and multiply and do matrix multiplication of this input data with the weights that has been generated, and then do matrix multiplication and then give it into this node, which is just another function, like which we call as activation function. You can think it as like a sigmoid function, which when get an output above 100, it will be activated, or when it get below 0, the new one won't get activated. So it's just like a mathematical function. um, like you can think it as a sine function like that, but the actual functions we use is sigmoid or ReLU function. So when we give input of data, and when it's multiplied with the weights, and when done activation function, that particular neuron will get activated or deactivated. So based on whether the neuron get activated or deactivated, the output will be generated. So if we see here in this example, by input, what I mean is particular features like age, salary, or education, and city or something, like whatever features we have in Excel column sheet. So whatever input data we give, the model will randomize a weight, and multiply it with the activation function, and then give the decision whether the new one is activated or not, like yes or no decision. So to explain it in a bit simpler way, let me show code here. So this is one kind of neural network called LSTM. When given an input data of music, it's able to generate the music on its own. So this is one complex example, but to put it in a simple way, first let me explain what we have learned before. We have learned linear regression, as I said already, like here. So here we learned a linear regression, right? So when given weight and height as input and output, the model will able to generate best fit line for the model. So here, so this is how the code is like. You can just try it if you go to the links like Kaggle or Colab. Um, I can also send this link. So these are like online tools where they give the infrastructure to just code online, and then uh, have it useful for other guys as well. Like, so if you see here, this is our data set of weight and height. So when given this input, so this is the actual plot the model is uh, predicted. Like for each weight, for the weight of 150, this is the height is the corresponding height is 65. So this is the simple scatter plot that we plot to see how the data is distributed. So when given this data, and just by this is just, as I said, this is very simple. Like we have abstract functions that can be used. So this is just one function that we call this linear regression, and we give this input data to fit the model. And when we give this input data to fit, the model will be able to draw this best fit line that generalizes the distribution of this data. So when this line is drawn, if you want to get the weight of say 260, whatever the corresponding y axis of this particular 260 of weight, that is might be 80. So the model will be able to predict based on this simple drawing the line and fitting the distribution of the data. So whatever we can think it of, this is a simple example, but to get to the, so here the model has just drawn a single line to predict the output based on the input. But if you want to generalize the data, if the data is more complicated, like in case of images or in case of music generation, the data will be like this. Like actually it will be like in a wave form. Uh, okay, yeah. So the if the data is in the waveform, we cannot just draw a single line to fit the model. So in that case, we definitely need a complex model to be trained. So actually, it's difficult for the machine learning models to find the best fitting function that can be done. But in case of neural network, if you see, we are just going to give the input, and the model will generate the weights and designate the, and we just be by giving the activation function, the model will be able to predict the output, and the complex function can be drawn by just giving the input and the labeled output. So think it as a like a black box. When given an input and output, we can get any solution we want, and we can use that model for any similar kind of input, and we can get the same output. So the that's something on neural networks. So let's get into the image classification. So how the model is able to classify an image given an input data. So we see here um, all the image classification and object detection. Even in on that video which I have shown, the object detection is done but based on the first classifying the images by drawing the bounding boxes here in the video I have shown here. Like it will first draw the bounding boxes and then try to predict the classify the bounding box based on the images. So okay. So here, if you see here, the when given multiple large amount of cat and dog images, the model will try to find the features that are relevant to cat and dog, and then when given the output as a cat or dog, the model will be able to predict it correctly. So by features, I mean, say here the dog will have sharp teeth or something, and uh, cat will be little puffy, and the color features will change for cat and dog. So based on these features, the model will try to assign the weights in each neurons and try to predict the output, whether it's a cat or dog. So that's how the neural network works. First, when you think of image, how the computers will see the images like accept pixel value. So each pixel of the images will be numbered, like for the dark image it will be a 0, or for the light image it will be 255. In case of colored images, it will have a three dimension of red, green and blue, and um, forget what is the uh, contrast level, and for green what is the pixel value. So for each value it will have It will have a pixel value, and based on that pixel value, this pixel value will be given as the input here. If you see here, for the input value, these pixel values will be given as an input, and the model will have the weight set generated, and based on that, it will understand the feature and give the output. So if you see here, when given the first layer, the model will try to find the lines and edges of the images, and in the second layer, the model will get into more depth of features by generalizing more and trying to understand each features like eyes, nose in case of face recognition, and at the final layer the model will be able to recognize the face of the person. So this is how the face recognition feature of images work. So how this what kind of neural network they are using for this kind of image classification or object detection, they are using what is called convolution neural network. So this is the first kind of neural networks that has been generated for image processing and computer vision. So when given an input image, what this convolution neural network does is it will take 9 into 9 matrix size of image and then give it as input to the kernel matrix, which would be like here shown here like a green box, and the blue box will be the actual image, and the green will just move towards each boxes and then do a matrix multiplication and try to identify each edges of the images, and then with each layer it will be able to identify more features, more general features like eyes of the cat, ears of the dog. Like it will try to analyze each feature and then at last classify whether the image is cat or dog. To if you want to do an intuitive of how this neural network function, I can show the actual website of simple how the convolutional neural network functions. We can see it visually here. Um, yeah. So if we see here, this is how the model architecture looks like. When given an image of a car, it's a three-dimensional. So it's a colored image. So the model will split into three channel inputs like red, green, and blue. And in the first layer, all the three inputs are given as input, and each pixel value is taken. See here, it takes this each value, each pixel value, and then multiplies it with the kernel matrix. So this is like if you are familiar with Photoshop, how they are doing filters means they are taking each pixel value and multiplying it with a matrix of these pixel values. So when multiplied with this kind of kernel matrices, it will try to analyze the image will be changed into a hard image or like more edged image, and then it will try to predict analyze what are the features in that image. So this is what it does. Like in each layer it will try to multiply it with a different kind of kernel matrix. So here the kernel matrix will be different, and in the blue channel, if you see, the kernel matrix will be different. So it will try to the what the model will do is it will try to assign the weights for this kernel matrix. So this is the actual weights that have been assigned by the model. So like this, it will do it in each layer, and when it goes for deeper into each layer, at last we will get nice understanding of each feature of the images, and in the final layer we will have labels of the data which will predict whether it's a sports score or whatever labels we want to predict. So at last it's able to predict it's a sports score with an accuracy of like 90%. So this is how the convolution neural network works in a nutshell, and this is how image detection or face recognition, also the object detection and the autonomous cars functions in a That's all. Yeah. So So one more interesting type of neural network, it's called as generative adversarial neural networks. So this would be interesting to most of the guys because this is what they are using in TikTok, Instagram, and even most of the people who have used the Face app to change their face into child or old aged people. So this is the neural network they are using to train the model. Even we can use it with this few lines of code and generate manipulate images as we wish. So this neural network is also used to begin deepfake. Like you would have seen deepfake videos a lot more than me. So you would have definitely known. So what this GAN does is it can create images that look like photographs of human faces, or it will try to create own image, but AI generated images or AI generated videos, but it's all a fake thing. But it's able to make it as so real that it will be hard to find. Like if you see here, can anyone guess which faces are fake here? Like which faces are fake, which faces are real? You can say it in comments. Yeah. Okay, I think there is no chat option here. No one can give comments or something. If anyone can guess it, they can say it. Hello? Is there anyone here? Like, hello? Yeah, yeah, one person is trying to guess. Okay. Hello? Yeah. So you
Hello, sir.
say, yeah, 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 go ahead.
I think it's C.
So you think C is fake one.
Yeah, I guess.
Okay, so all others are real one. Okay.
Yeah,
So any other guesses?
I think A.
E. So A is real one. So just say which one is fake. So
Yeah,
one
D.
D is fake. Okay. Okay. So few had said that C is fake, and few had said D is fake. Okay. But the actual answer is all the four images are fake here. So actually, actually, if you go to, you can just try it. This is a website called "This Person Does Not Exist." This all these images here are generated by GAN. So all those images which are generated here, you can just refresh it and see. So all these spaces are generated by generative adversarial neural network. So you can just try it for fun. And also there are a lot of things we can do with making the image as a cartoon image. And even you would have seen like Prisma, that effect, those all those effects are generated by GANs. So how this GANs work? So that would be interesting for us, because how this GAN work is, when given an real faces of all the images, what the neural network does is it will just try to generate faces from random noise, like without any image pixels. It will generate the pixels of its own and try to make draw or make image of its own. So this is what this generator neural network does. When it does, what the discriminator does is it will distinguish whether what all the images generated by generator is real or fake. So when the discriminator says you generated a fake image, the generator will go back and try to again initialize the weight and try to make another pixel, another type of image, and then generate a new face, and again give it to discriminator and ask it to predict whether it's real or fake. So once the discriminator again makes it gives it a fake, again the model trains and gives it image until it fools the discriminator to make it real. So it's like a game where the generator and discriminator play to where the generator tries to fool discriminator to make it as a to give it as a real input. So by just giving a few kinds of images to the discriminator, few real images to discriminator, the discriminator will understand the features of the real images. And when the generator tries to fool discriminator, the discriminator won't fool as easily as we can think. So it will take a lot of iteration for the model to generate and for the generator to fool the discriminator. So this is how the GANs work. So enough of computer vision. Let's go for NLP, where so first how we all are interested with Siri and Alexa. So how it's able to recognize our voice and able to act based on our input, voice input. So what it does is like when how they actually trained this kind of model is they have given a enormous amount of data, like the data will have the your voice and labeled output. Like if I say hello, that recorded voice plus the input will be given as hello and given into the model to train. So likewise, they have trained a humongous amount of data with the input and the voice signal and the output, and the model will able to be trained. And once the model is trained, whatever voice input you give, it's able to act based on that. So if you see here, tell me about my day. So each word signal, they cannot train the model for each input. Like you can say blah, 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 but it cannot understand what you said. Like but what the model does is it will split each word you said, and it will already have for each word what is the input signal, and based on that it will just guess what is the word said. So once the model is trained on that, we can just use it in Siri and other voice assistant tools. So even now we can easily do this by using this deep speech, which is a library which is open source. Everyone can use it. Um, just by giving the our voice signals to it, it will be able to predict on what all the inputs we give. So this is using automated speech recognition and natural language understanding under the hood to process it. So when you say, tell me about my day, it will get the input from the voice signal and frame the phrase. After forming the sentence, it has to understand the actual semantic meaning of the sentence. Like, tell me about means what it means actually. So it has to understand. For that, we are using natural language understanding. So there are a lot of models for it. Like, if you go deeper into that, there is a recent development from Google which is called BERT, uh, which we can easily train by just if you study for half an hour, you can just easily train with that model, and then you can make the model understand whatever you say. So one of the other major use cases of machine learning and AI in terms of web is all the searches, all the search engines, and all the Google ads, Facebook ads we see, or when you have uh, browsed for a shoe in your Google page, it's able to automatically show it in the ad. What how it does is under the hood it saves your browsing history as cookies and analyze those data, and then able to recommend what are the best interest products for you. So that's how machine learning does it. And few other applications of deep learning, you can think it as you can have image recognition, NLP, and as we have discussed, speech recognition. And there are a lot of use cases in um, medical and healthcare system. Even for COVID vaccine discovery, they are using AI to predict what kind of drugs can be used to heal the uh, disease. Actually, also, so we can discuss about self-driving cars next. Okay. So for for the as we are all from electrical background, this would be definitely useful for most of the guys. Like all the self-driving cars are using some kind of electrical chips and also image recognition and sensor recognition to automate and run the car. So how the self-driving cars work? What are all the components that are needed for the self-driving cars? In terms of hardware, we know already that we need definitely cameras and sensors. So for the cars, it's just not a regular cameras. Like we need some kind of sensor fit cameras that can make the model do the computer vision in real time. So we need complex algorithms to be fully complement the images they receive. So everything has to be done in real time, like in terms of milliseconds. As in the first frame, it sees an image. It should be able to classify the objects that it has seen. So as I was seen here in my model training, for each frame, it detects a person. It detects what are all the things there in that frame. So this is done by giving a video's input, but this is not so fast. Like it cannot do it in real time very fast. So for that, we need high-tech GPUs, and that can do real-time parallel processing. So for that, we need um, high-tech central computers that are that has to be placed, so that can manipulate the images in real time as in matter of seconds. And it's not just on cameras. Like we need a 360 view of full cameras, so we need at least 8 external facing cameras, and also a video cameras to detect traffic lights and road signs and other things. So not only cameras, not only computer vision, we also need sensors that can detect the depth of the how much distance a person is there from the car. So how much distance the other car is in front of this car. So for that we need some kind of sensors. For that we use radar and lidar. So radar is actually one of the primary means that self-driving cars utilize to see along with the lidar. So on the radar is actually the somewhat lowest resolution compared to LiDAR, but radar on the other hand, which uses radio wave-based signals, it can propagate things like rain, snow, and it can also predict the weather conditions that are there in the environment. So for detecting this distance and other things, we use lidar. Lidar also uses for what we see on top of self-driving cars, like spinning around. We see light detection and raging. So this is used to see the what is the surrounding and analyze what is happening on the edges of the road, or if someone is trespassing the signals. So we also need other sensors like GPS tracking and ultrasonic sensors and inertial sensors to gain a full picture of what the car is doing, as well as what's actually occurring around it. So all these sensors, images, and cameras under the hood uses AI, and you definitely need to know coding. And so for fitting the sensors, we would have known about electronic components, but for in terms of training the model, um we need to do programming and understand what is happening for the model to predict of the surrounding. Um, so one of the main factors for autonomous cars is every artificial intelligence model needs input data to be trained. For the input data, we need at least like 1 month of 1 month of call recorded video for the model to be trained. So what recently Uber has done is they have designed the autonomous car and made it run along and record the video for almost 3 months to record all its surroundings and what all the unexceptional cases it could occur, and they have recorded everything and fed it as the input model to train. So if you think of autonomous cars, the best thing, the most recent advancement is all in Tesla. So they have done recently um, well autonomous cars, and the autopilot mode is one of the best in among all other car industries. So here the as I have explained already, what all the each sensors is useful for, like for radar that tracks the direction and speed of objects, that uses radio waves, and it's mainly used for detecting the weather conditions. And lidar is used to detect the depth of the objects in front of it and around it. So, like if another cog is there, it has to predict what is the depth, whether there is a possibility of collision or whether the cog has to stop or not. And for computer vision, as we have discussed already, we have to do object detection and understand what is the object there and classify it and run the cog based on it. And there are other complementary sensors like audio and other things, connectivity between cars, okay, like maps, GPS, and other things. So, for in terms of algorithm, there are regression algorithm that detects that does the object detection and compares variables to predict an object position and distance, like whether the car is how much distance, how much speed it's going, whether there is possibility of hitting or not, like that. And for decision making, whether the car has to stop or it can go around. So this is the biggest topic, like it's the most uh, problematic topic actually. Like if uh, person is crossing and if the car is going at 135 speed, and whether the car has to stop or hit the person. If the car doesn't stop, the person on the road will die. If the car is trying to stop, it will turn around, fall, and it will hurt the actual driver. So in that case, what the car can do, that's toughest decision to make. So that's why none of the companies have made uh, autonomous cars as fully available in the market. So these kind of decisions have to be clearly designed, and these algorithms has to be definitely made. So those things have been done, and I think within 3-4 years we will have autonomous cars running in in all the markets, and we could be able to see it. So there is also pattern recognition algorithm that helps to reduce the data set by finding patterns, and whether how much for the parking spaces it's very much useful, and for the clustering for signals and other things. And so these are the some of the issues that are being faced recently. self-driving safety and complexity and unpredictable agent like unexceptional cases. So what is there for artificial intelligence in terms of electrical engineering? So for electrical engineering students, we definitely need to understand the fact that most of the industries are moving towards fourth revolution. That is, they are trying to make every machines like uh, motors or generators, whatever you could think of. Everything is going to be made autonomous. Like whatever the task that is too repetitive or does has to be done by unskilled workers, all those things are going to be automated. And this is the thing that all the industries are moving towards, like industry 4.4. What is industry 4.4? So it's actually like an automation and a data exchange in manufacturing technologies. Like all the machines are like smart machines, and they have internet connectivity and cloud computing. Like we have Amazon AWS, Microsoft Azure. So all these platforms are giving cloud platforms. I think everyone would have known what is cloud platform. If not, what is it actually means? Instead of having virtual servers, instead of having actual servers that is being maintained by each company, all the companies are moving towards cloud platform where everything is all the servers are there in big companies like Amazon, Google. They have their big data centers, and all the servers are running in their data centers. But how the company access these servers is through means of cloud computing. They just have it connected as server, virtual server, like all the computers will be connected to virtual servers that are there in the data centers, and they can access it using cloud computing. So that's cloud computing. And um, we have us if all the machines are connected to internet, like in case of Internet of Things, there will be humongous amount of data, and uh, all the machines will be interconnected using the internet connectivity. And so all the data generated will be analyzed using machine learning, and all the machines will be running autonomously. So this is not only that, it includes also like advanced data analytics, edge intelligence, and as I already said, cloud computing and big data, and uh, even for IoT of things, Internet of Things, we have a lot of improvement in that field as well. Like when all the devices are connected with the internet, they can easily do high-tech machine learning models into a simple device, and then it will be easy for them to handle the machines by without being actually there. And we have also seen a lot of improvement in augmented reality, like even Apple phone. We would have seen how it's doing augmented reality by generating a dinosaur image inside our camera. So those kind of things can be really useful for industries to actually repair or maintain machines. And autonomous robots are being placed everywhere. In even we would have seen in Amazon warehouses, and uh, every industry is doing autonomous robots rather than having a manual worker right now. And so how these artificial neural networks can be used in power systems. So, in a nutshell, we can use artificial intelligence in a lot of various of things. Like if you want to predict what will be the power generation for the next month, we just have to put the all the power consumption of this month, to the machine learning model, then it will be able to predict what will be the uh, expected power generation for the next month. So in that case, if we know what will be happen in the future, we can do power generation accordingly, um, and also it can be used for power consumption, and even for in our household we can record what all the energy consumption for each day, and then give that input as to the model, and our machine learning model will be able to predict what will be our consumption for the next month, and we can use the electricity accordingly. So for in terms of energy consumption, I have written a code here which I will quickly walk through. So it's as simple as that. We can finish it within just like 50 or 30 lines of code. We can predict what will be the energy consumption for the next month. So if you see, this is the input data uh, for each day, what each time, what is the energy consumption. If you give it to the model, so this is just a artificial neural network model. So this is a library which we can use to build artificial intelligence neural networks. Like it's called as Keras, and we have few other libraries called TensorFlow and PyTorch, which we can use it to train our neural network models. So just I'm doing some few pre-processing here, and so this is the actual model. So I have stacked like four models here, four LSTM models. LSTM models is one kind of neural network, long short-term memory. So when given all the input, so this is how the model trains actually. So for each epoch is called, actually it's actually iteration. For each iteration, what is the loss we are getting? So for each iteration, this loss will be reduced
Excuse me,
for each.
Thambi. PPT only visible.
Oh, okay, sorry. Okay, I'm sorry about that. I didn't see the... Okay, so let me start it again. Uh, okay, so this is the actual data set we have. So for each day, what is the energy generated? So with this data set, we can train our model to predict what will be the energy consumption for the next month. So for this, I used a library called Keras, which is a very good library for building neural network models. There's also TensorFlow library, and you can also use PyTorch, which are designed by Facebook. So just before putting into the model, we need to do few pre-processing, like the dates are here randomized. So I'm just doing so few pre-processing steps here, and once it's done, this is the actual model. So we can train the model with just even you can train the model with just this one line. This is just one layer, but I have given three layers here, and uh, I'm using LSTM. This is one kind of neural network called a long short-term memory. So um, when given with this four new layers, we are able to get a really good output. So we can add few more layers. We want to do get more accuracy, and this is how the model trains. Like I have given 100 iteration. So epoch is actually iteration. Um, so the 100 iteration, for each iteration, if you see, we are getting the loss decreased. So this is the first loss we are getting. So the main objective of training the model is to reduce the loss function. So once the model is trained, we can give any number of iterations, so it's based on your output. So first I gave 10 iteration, it didn't get good accuracy, so after that I gave a few more epochs. So these are all few hyperparameters which we have to tune, like how many layers we have to add, how many epochs we have to give. So those things we have to decide, like based on our input data and how much accuracy we want to get. So once the model is trained, we can try to evaluate whether the model is well trained or not. So once it's done, we can measure the error rate, and then if you see here, this blue line is the actual prediction. It's the actual um, flow of the data. So this is so the actual input is drawn as a blue line here and red line here, and the predicted value is red. So the model is able to um, understand the complex function here. By just giving the input, it's able to draw exactly what is the underlying pattern in the data, and it's able to predict what will be the next month uh, electricity generation. So once we have trained the model, we can give any for any month we can give the data, and then it will predict what will be the energy generation for the next month. So, but we also need to do a few training afterwards. Like the data will not be the same for each year. So for each year, we have to again train the model and then ask it to predict for the next month. So training the model is as simple as that. So you have seen how the artificial intelligence can be used in various things, like for energy consumption and for prediction of energy generation. We can also see it for how an ANN can be used to in the power systems. For example, we can use it to understand what is the value of inductance, capacitance, resistance in a transmission line, and also we can use computer vision to along with the drones to see whether there is any fault in the electrical lines without actually a man having the need to go there and manually repair it. We can make it run and do computer vision to see all the electrical lines, and all the electrical power system can be maintained with just the drones. And if there is any fault or any wearing of the wires, the the computation model will be able to predict any fault in the machines, and that can be immediately rectified, notified to the person, and they can go on there and do the maintenance. So computer vision can be also used in various power generation, power systems to just monitor the machines. If there is overheated, we can use heat maps to see whether a machine is overheated, and if it is overheated, then we can immediately alert uh, the person in charge. So fuzzy logic is also using is also some kind of um, algorithms that are designed by AI that can be used in power systems and electrical systems. So fuzzy logic is the way uh, we decide something, like it's just like a decision tree that we have discussed already. Just based on a definitive input, it will just designate what will happen, what are the algorithms it has to follow. Also, there is we have discussed some general use cases of AI, but we can do some knowledge-based AI. That is, we can build an AI system so specific to a particular field. That is, we can give all the inputs of vertical engineering that is only specific to that can be only used in a particular kind of industry. So in that case, we call it expert system because we input it with all the knowledge of the particular field, and the model will be well trained to do that particular task. So there are a lot of applications in okay, in power systems, like in power generation and expansion of planning, power system reliability, transmission exemption, and also how to control the power system, like voltage controller, stability control, how to control the power flow. And I think in most of the power plants now they are using uh, AI, like to predict what will be the energy consumption of the city for the next month, so that they can generate the power accordingly to the need. And even they are using it for factory devices, electricity markets for bidding. Okay, so that's it for me today. So is there any questions? Like
Hello, can you hear me? This is Vinod.
yeah, yes. Hi, Vinod.
Yeah.
Yeah,
Yes. You explained like image classification, right? We
yeah,
can do the same thing in machine learning as well as in neural network artificial intelligence.
yeah.
So how will we decide that? So I can apply machine learning for this or deep learning for this?
So one of the
How to decide that?
major, uh, 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 so one of the major advantage of deep learning is you will get better accuracy. You will get better classification in terms of image classification, because what machine learning does is machine learning is having a few set of algorithms. Like there are, you can count what all the machine learning algorithms that are there right now. Like you have linear regression, logistic regression, decision trees, gradient boosting. So there are only like 15 set of algorithms that can be used for machine learning. So these algorithms are generalized to one, and when you wanted to do it for image classification, uh, when you wanted to do a regression, it will treat both classification and regression task as the same thing. So these kind of machine learning models will fetch a good result only with a few amounts of data. But if you wanted to do get a good accuracy, mostly we will go for deep learning. But one of the drawback of deep learning is we cannot train a robust model. We cannot train a good model of deep learning with a few amounts of data. For machine learning, we can just give like 1,000 data points, 1,000 images maybe, and then the model will give like 85-90% accuracy. But in case of deep learning, you have to give like at least 10,000 images for the basic neural network model to be trained. But if you see, there are a lot of neural network model that have been already pre-trained with like 1 million images. There is some models called ResNet, ImageNet images. So these models have been already pre-trained with images, so they can get the features of the images already. So when you give a few hundred images of image and cat, it will be able to predict easily. So the idea is now everyone is using deep learning because we can use the advantage of pre-trained models. Like if you want to do image classification, you can just load the pre-trained model, which is called like ResNet, and you can also use the model which I used here for object detection, which is YOLO. So you can just take that model, which already has all the knowledge of image classification pre-trained. It is built on complex structure of convolution neural networks. Like it is trained on 50 layers of neural network, so it knows all the image features, all the edges to be detected. So when you just give 100 or 200 images of the particular image classification task, like you wanted to do a classification of all the bags you have, like a bag or trolley or something. If you just give that image set to the pre-trained model, it will be able to predict it with more accuracy. Like because it's already pre-trained on humongous amount of data. So it's just like you want to use already pre-trained model. Yeah.
Okay. Is that like we need more data for deep learning compared to machine learning models?
Yeah, definitely. For deep learning model, you definitely need to have few more data for it to understand the underlying features in the data. Yeah.
So how about the duplicate data in machine learning? Maybe for one record, I'll stamp it as cat, and for the same relevant record, I may stamp it as dog too. So
So
how can we expect that accuracy there if
you
there are
say
some data with some errors?
you are going to feed in data with errors. Okay.
How
In case
machine
of
learning will handle that?
actually
Will machine
for
learning handle that, or
no, it will be like biased to whatever the input data you give. So if you give a wrong data, it will just try to understand the pattern in the wrong data. So it will not be so efficient as you think. So that's why we do a lot of data pre-processing, lot of exploration of the data. So before feeding into the model, we must have the data well prepared. Like the data has to be a real representation of what we wanted to achieve. So without data processing, it's the model will not be accurate and you cannot achieve good accuracy. So the most of the time, if you wanted to be a data scientist or AI guy, the most of the time you will spend on collecting the data, collecting the right data, and doing a lot of data pre-processing. Like how the model needs the data is also like important. We cannot just give any data. We have to give the data as the model will accept. So we have to do few pre-processing, and that's how the model functions. Yeah. So if you speak about duplicate data, I think we have few functions for duplicacy, but we have to achieve it before feeding into the model. So yeah, so we can handle the duplicacy. We usually handle duplicacy by if there is duplicate data, like the data is repeated, we can remove it with the data pre-processing. But if the data is fake or it is not a good representation of the actual data, we cannot do anything. We have to definitely remove that fake data. Yeah.
yeah? So in when I should decide, like instead of doing the traditional programming, I have to go for machine learning. I can achieve the same thing with the traditional programming, like with 100%
Yeah, but
accuracy.
the problem is
Simply like if
you
I
have
want
to
to compare,
mm,
yeah,
yeah, go to it. Finish the question.
yeah.
Yeah.
If I want to simply compare, like find the person who is having salary more than 10,000. Some
Mm.
conditions I can write there, right?
Yeah, you can do that, but that's the beauty of machine learning. We don't need to give the condition that the machine has to follow. But if what if we give the wrong condition? What if the function is too complex? You're saying detecting a salary, but what if you wanted to classify images? You cannot write the manually function for each pixel. If you find this pixel, you have to classify it as a cat or dog. So those kind of complex functions we cannot do. So for that, that's why we use machine learning, because we just have to put in the input and the label data. Then just the machine will try to learn the underlying function and the underlying pattern in the data and get the good output. Yeah,
Yeah.
but you can go for traditional programming, but it will be too complex and it will be like manually doing everything. But oh, oh,
But that
but
gives 100% accuracy, right? Definitely, it will give me the list of people who is having salary more than 10,000. But machine learning is going to give me just 80 or 90% accuracy, saying some person is having less than some 10,000 salary too.
yeah, so what if you're getting a data that is not about getting the salary, but you have like take the power system example. Uh, you have a temperature feature and climate feature and voltage current feature, and you're asked to find what is the energy consumption that will be there in the next month. So in that case, what you will do, you cannot write the function if the temperature is above and if the voltage is this much, if the load is this much, then the electricity will be this much. So you cannot write the manual function for each step, and it will be like it will be like manually doing it for weeks and weeks just to do it for that particular system. So why not we can use the machine learning, just give the input and output and let the machine learn. And even if the accuracy is 80, 90, we can again make it as 95, 98 by doing hyperparameter tuning, by adjusting the parameters and adding few more layers, for example, we can achieve the good accuracy. So it is now a good idea to do manual programming in case of when we have a better option of machine learning. Yeah.
Yeah, right. Fine, thanks. My only point is like maybe if I'm predicting the power for next month. Okay, so say like expected is 100, but I predicted it as 50. How are we going to meet the demand next 50?
Yeah, that's why when we train the model, we won't just train the model without having a test data set. So what we do actually is when we have a data set, we split it into 70% training and 30% test data set. So we train the model with this 70% training by giving the input and output, and see how the model performs and whether we are getting good accuracy or not. So once the model is trained, we will give this test data with just input without output, and we will try to test how this model is performing. So with the unseen data, if the model performs well, like in case if we give the unseen data and if the model gives us 50 instead of 100 for the next month energy consumption, then we at the time itself we would know that the model is not doing well. So we will again do the training and try to predict, try to make the model do well with the test data. So without
Okay, so
doing these steps, we
can we
cannot.
expect the same accuracy whatever we got in while training the model when we apply with the new data? Can we expect the same accuracy there?
Yeah, it will never be the same accuracy when we do it with the training data and test data. If we get the accuracy of 95% with the training data, we will be getting only 90 or 85. So the model will only have to be generalized well. It's not like we have to get if we give 100% in training and 80% in test data means the model is like it's overfitting. It's just memorizing the data that for this input it has to give this output. It will be like memorizing. So in that case, we have to do some regularization techniques for the model to do well on test data. So our main goal is for the model has to be do well on text data. So uh, so that case we will try to make the model do well for only the test data and generalize well. Yeah.
Okay, fine, thanks.
Yeah, thank you, Vinod. Do anyone have any other questions?
Yes,
Hello, Sudha.
Sundaravil, I have one doubt, one question.
Yeah, sure.
Okay, what type of tool used in a linear regression to fit? No, what type of tool?
Tool you are asking about functions or library?
The linear regression you are fitting now online. No, that is I'm asking the software. Yes.
Yeah, I was using Python function and the library is scikit-learn, sklearn. Wait, I can show.
Python, okay. And also stated and the reinforcement.
Mm-hmm. Yeah.
Okay, and the reinforcement and just for awarding and punishments. Okay, how is going to be getting to be trained for that?
Yeah, for training the reinforcement learning, it will take a lot of iterations. Like we will just put the model with a few input weights and put it into the environment, and the model will exploit the environment. It will go all around the environment and try to understand what is around it, and it will try to make a step. For each step, we will assign whether it's a reward or punishment. So for each step, it will get a reward, and it will have a it will have a memory of what it has happened in the previous step. So
Okay.
for each step, it will have a previous step analysis with the current step, and based on the exploitation of the environment and analysis of the previous steps, it will just try to make it better for the next step. Yeah.
That means it may increase the computational cost also.
Yeah, that's why it will take a lot of computation
Oh.
power. You can only train it with the GPUs,
Okay.
parallel processing.
Okay. Another one, that is, you told that only the raw data are fed to that CNN raw data. Okay, that features your shaded lines and edges, and what type of features you are considered only lines and edges?
So there are various steps in convolution neural network. For each layer, for first layer, it cannot directly go for recognizing the actual faces or actual dog features. First, it will try to analyze the initial edges. So whenever you do a Photoshop editing, if you make it as a black and white and increase the context, you will only get the edges of a building or like that. So that is the first layer. It does it multiplies each pixel with a kernel vector that is actually a filter. It's like a filter that tries to get the edges of the images. So once it gets the edges, it will do max pooling. Max pooling is if there is 4 into 4 matrix of pixel, it will make it as 1 pixel. Like it will take the maximum value that is there in the focus 4 pixel. So when it does that max pooling, it will generalize 4 pixel into 1 pixel. In that case, it will get a generalize of a particular eye or a particular nose, a small image, and again it does a convolution layer, and it will get more general feature like face like that. So with each layer, it will try to get more features like that. Yeah.
Okay, what about the computational time? No?
For CNN, if you can use you can use this Collab notebook. They are giving free GPUs for everyone, and it will take just 15 minutes to train a simple classifier of cat dog. It won't take much time. Yeah.
Okay, next,
Yeah.
self-driving car. What type of processor to fit AI in a self-driving car? What type of processor to fit AI?
I exactly don't know what processor they're using, but I was reading a paper that they use actually Tesla is using TPUs. Those are high-tech processors that can do parallel processing in real time. So definitely they would use high-tech processors, but I don't know what exactly the processor and what all the hardware features they are using. Yeah.
Okay, are you used any software for weight calculation? You are showing that no, the artificial neural network weight calculation that is in AI. Okay, is it software or doing something like that? It's
So
actually
these
good.
weights are generated by AI, but we cannot actually see what are the weight. But we can save the weights and see it in the output stage. But if you want to visually see what is happening inside the neural network, nobody knows what is happening inside neural network. Just we can do the analysis and save the weights, and we can see what is the weight it has formed. But we cannot see it while the training is going on. Yeah. Is it the question you asked? I didn't get.
Yeah. Okay.
Only one doubt. Yes, sir.
Okay, maybe carry on, ma'am. Okay.
Yeah.
Yes. I mean, the energy level prediction that you discussed, in that your data is in the form of CSV file, right? And you uploaded that CSV file in that Jupyter, you analyzed, right? But
Yes.
my question is, if it is that Google car self-driving system where we have to we in the hand the data is in the form of collection of images and the sensory data. Is it
Yes.
possible to upload all the sensory data and all the images with the use of this Jupyter Jupyter, or we have to move to some other platform in order to do such a kind of analysis that you told, right? Regression and all the kind of prediction, etc. For that, this Jupyter is enough, or we have to move to some other platform.
No, we can use any kind of platform we wish, but why I used Jupyter is it's easy to visualize what's happening in each step. So we can train any model in Jupyter or Colab Notebook. We can just here I have uploaded a video and asked it to predict for each frame. So likewise, you can give any video input or recorded signal input, or just we want to make the Python code try to understand what is the input. Like for CSV file, I used this pandas read CSV function, and for videos we have YOLO detection function. So for each thing there is a function. Just we have to give it as give that input to that function and make it analyze the data and inspector in terms of tools or platforms we use for coding. um, we can use Jupyter Colab Notebook, or we can also use uh, PyCharm or whatever IDE that can be used for Python. Also, we can use in case you are going to use all programming language, you have our studio. So whatever IDE, that doesn't matter, but it's just that what library you use, whether you have installed that library in that system, and if you are going for Linux environment, then you can do even you can do everything in command line. Just uh, in Windows PowerShell itself, we can do everything. So it doesn't matter. It's not the matter of what platform you use, just that what function you use, what programming language we are going to use. So that matters. Yeah.
Thank you. Thank you. Thank you.
Yeah.
Hello, sir.
Yes.
Sir, this is Geeta, Resource Associate from EIT Vellore.
Yeah.
Just I want to know that which AI algorithm will be more suitable for to find the remaining useful life of any electrical machine, like which will be more suitable.
Okay.
So
What
just
kind of data you have? Like what kind of features we have? The
like
column.
in the numerical data, sir, not in the image.
Okay. So in terms of classification for machine learning, you can use this gradient boosting. Type it. Or gradient boosting or XGBoost. So this is one of the best model in machine learning for classification. So if you're going to use deep learning, you can directly use this Keras sequential functions. So those would be good for numerical classification.
For prediction, sir, in case of prediction, just I want to know the remaining useful life of a machine. So which will
Okay,
be
so it will be like a time. It will be like a time.
prediction, like a regression, yeah.
Okay, this XGBoost can be used for both classification and regression, so that doesn't matter much. For if you want to do real-time prediction, you can use Keras, LSTM. Layer is good for time series prediction, like what will happen in terms of time and what will happen in the uh, prediction future. And you can put actually you can feed the data into I think for the prediction of what is the actual is it like a time series or is it like what kind of
Yeah, it's like a time series.
yeah, definitely you can go for LSTM because even for energy load prediction I used LSTM and it resulted a good output.
Yeah. Okay, sir. And also I have another doubt. Is this AI results will vary with this different software tools, sir? Maybe now the currently people working on Python. So this Python will give a more accurate results or nothing else. It depends on the configuration of the PC.
No, actually, you can use any programming language. You can use Python, you can use R, you can use Java. But the fact most people use Python is it's easy to code. It's you have a lot of libraries like TensorFlow, Keras, PyTorch. So these things are well built in Python, and so you can use easily you can easily code and get the output very quickly. And we have the ID like Collab, where they give free GPUs and you can easily train the model. And so Python is pretty much used everywhere for AI nowadays. So it's good to learn Python rather than any other language.
Okay, sir. Since now I'm working with the LabVIEW real-time applications, that's why I'm asking whether this Python will be more better than the LabVIEW software.
Yeah, definitely Python will be very useful for you if you use. Are you using MATLAB or something? What is the lab function you are using?
Yeah, MATLAB is also there. LabVIEW software.
Oh, okay, okay.
Different from the real-time.
Okay.
Even in the industry side, they are using this real-time this LabVIEW software for the monitoring of machines.
Okay. So
That's why I'm asking whether this Python is more better and comfortable than this or any other previous softwares.
in terms of software, we can use it for only limited functionalities. But if you think Python, you can do anything with Python. You can do your own software. You can do your own analysis easily, rather than depending on your software. I would say, like, yeah.
Okay, sir. Thank you. And another doubt. And you mentioned that the CNN will be very good for this image classification. So in case if I am converting my numerical data into an image, what will the results? Sir? It will give the same accuracy or?
You're going to convert your numerical data into an image.
Image, yeah. If I convert my like that one dimension into that image, then I'm feeding into a CNN. This accuracy will be same or it will have some like bias or something.
So it depends on the input data you're giving actually. But in terms of CNN can be used for even words as input, even for numerical prediction. But CNN does better for image, so that's why people use CNN for image classification in the first place. But as you see, the CNN has got old, I would say, because nowadays there are a lot of other models. There is Deductron by Facebook, and there are a lot of models that have been upcoming in the recent days. So it's good that you keep updated with the recent models, and these recent models give better accuracy than the actual CNN. Like even I said to the GuessNet, which is composed of lot of CNN, is will give better accuracy than you trying to build the model from scratch. So these models have been already pre-trained. You have to just load the model and they give you a input data and just to see the model getting better accuracy than just using a regular CNN from the scratch.
Okay, sir. Last question. I'm sorry for taking your time.
No. Yeah.
Sir, and you mentioned in the self-driving car, and what will be the AI algorithm used for this engine, sir? For like engine monitoring or like to just check the condition of the engine. Is any AI is used for this engine maintenance or something else?
For engine maintenance or how the engine functions.
Maybe what AI algorithm is actually in real time they are using for this engine, whatever the engine maintenance or like to check the condition of the engine.
So if you want to do a few simulation of what is happening in autonomous cars, you can use Donkey Car. So they have a real-time simulation of what is happening in the engines of the autonomous cars. So in terms of in terms of what was the question actually?
What type of AI algorithm is used for like engine condition maintenance or something else? To check the engine, is any AI algorithm is used in the real time? Like they are using any real time algorithms in engines.
So for as I said already, that will be detecting the heat signals and the signals from that is coming out of the process to see whether the machine is in good condition or not, and it's just a matter of heat map classification whether the machine is running good, or based on how the machine actually runs we can just detect get the input from the sensors and feed into the model, and then just see whether the machine is in good condition or not. But I really don't know how what they're doing actually in Tesla or something. I have just used the simulation software to just to see how the car runs. I just have configured the object detection and computer vision, those kind of things. How the car detects the image and predicts the whether to go speed or how to control the throttle. So those kind of things. So other than that, I don't know how to maintain the machines. So those kind of things. Yeah.
Okay. Thank you, sir. Thank you so much. And your presentation was very much helpful for my research. Thank you, sir.
Okay.
Thank you.
Thank you.
Yeah.
Thanks a lot. Yeah. So.
Hello.
Yeah. Hello, sir.
Hello, sir. Hello,
Sir.
Sundar.
Sir.
Are you want to ask any question?
Yeah. Anyone having any questions?
Anybody want to ask any question?
No questions, sir. Sundarvel, nice presentation.
Thank
All
you,
the
sir.
best.
Thank you so much.
Yeah.
Thanks for this opportunity. Thanks everyone for attending and bearing with my lecture. Yeah. Thank you.
Thank you,
Sundararajan.
Okay, very nice presentation. Very good presentation. Okay.
Thank you, sir. Thank you. Thank you very much.
Sundararajan.
Yeah, sir.
Okay.
Thank you.
Okay, you have done a nice presentation in the neural network.